Alright guys, it's time to play some League of Legends.
Awesome. I've been waiting all day for this. Let me just log on.
Oh no, all of our passwords have been reset.
That's fine. We can just use the security question.
Did you guys also set your security question as the 2017 AP Calculus Free Response question number 5?
Hey,
Obviously.
Now we have to do math.
No, it's okay. I can just look up the key.
Hey man, we have to do the math.
But why?
Because of academic honesty, Razak. God, didn't you pay attention at all in Miss Louie's class?
So part A of the security question states that for t which is greater than or equal to 0, but less than or equal to 8, when this particle p moving to the left. And the key concept here is to recognize that velocity is a vector quantity. So when velocity is negative, the particle is moving to the left, but when velocity is positive, the particle is moving to the right. So what this question is really asking is when is velocity negative? Because velocity being negative implies that particle is moving to the left. So we're given the position function, which is natural log of t squared minus 2t plus 10. So when we take the derivative of this position function, we can get the velocity function, which is 1 over t squared minus 2t plus 10. And we do the chain rule of this function, and we get 2t minus 2. So velocity function is going to equal to 2t minus 2 over t squared minus 2t plus 10. Now we also have to find the critical points to know where velocity is positive and where velocity is negative. And remember, the critical point occurs when function equals to 0 or when function is undefined. So we first set this function equals to 0, then we get 2t minus 2 equals 0. 2 times t minus 1 equals to 0, so t is 1. And also when function is undefined, t squared minus 2t plus 10 equals to 0. And I put this function into a vertex form, and I got t minus 1 squared plus 9 equals to 0, so vertex is at 1, 9. And since this function is positive, facing upwards, this also implies that this function never touches the x-axis. So this function is always positive for all t and never 0. So we don't have to worry about when this function is undefined. And so now we know that the critical point is when t equals 1. We do the sign chart and we determine that from left of 1, velocity is negative. From right of 1, velocity is positive. So finally we can say that velocity is negative when t is greater than or equal to 0 and less than 1. Not less than or equal to 1, because when t equals 1, velocity is 0. And so our answer would be particle p is moving to the left when t is greater than or equal to 0 and less than 1. So you get 1 point for finding the derivative of the position function and thus the velocity function. And you get 1 point for identifying the correct interval. So this is a 2-point question. And common mistake people could make is not recognizing that velocity is a vector quantity, and thus that when velocity is negative, the particle is moving to the left, and when velocity is positive, the particle is moving to the right. And you can also make some algebraic errors on this step, finding the critical points. So and one other common mistake people could make is saying that particle p is moving to the left when t is greater than or equal to 0 and less than or equal to 1, when it's actually just less than 1, because when t equals 1, velocity is just 0. And another mistake could be forgetting the chain rule, because this is a function inside of the function t squared minus 2t plus 10, so you always have to do the chain rule of this function, getting 2t minus 2. So thank you.
Okay, so for part B of the FRQ, the question is for the interval 0 is less than or equal to t is less than or equal to 8. Find all times t during which the two particles travel in the same direction. And the first important thing to know how to do this question is to know that in order for particles to be traveling in the same direction, their velocities have to have the same signs. That's because velocity is a vector quantity. So if they're both positive, they're both going the same direction of right. If they're both negative, they're both going the same direction of left. So the first step to find the signs of v of q of t is to make the velocity of particle q equal to 0, and then you solve it out, and you get the x-intercepts for the graph of the velocity of particle q are 5 and 3. And then you use those, since you know that the graph of velocity of particle q is a parabola. You can make a sign chart with that, and that gives you a sign chart of the velocity of particle q is positive from 0 to 3, negative from 3 to 5, and positive from 5 to 8. And all you have to do at this point is take the sign chart that we got earlier from question A and compare it. So you compare the velocity of particle P to the velocity of particle Q, and you match up the intervals at which they are both the same sign. And that gives you 1 to 3 and 5 to 8. And an important thing to remember is that because at 1, 3, and 5, these are all at points where on one of the graphs it's intersecting at the x-axis, and at the other graph it is not. Those are all less than. Those are not less than or equal to. But at 8, it is less than or equal to, because they're both above at the end of the interval. So you end up with the answer of the particles are moving in the same direction on the interval of 1 is less than t is less than 3, and 5 is less than t is less than or equal to 8, since the velocity of particle p and the velocity of particle q have the same sign on these intervals. So this is a 2-point question. You get 1 point for identifying both of these intervals, and you get 1 point for the analysis, which is stating that they're on this interval and they are the same because their velocity is the same signs. So common mistakes to make for this question would be only putting one of the intervals here. So if you only found the interval for the velocity of particle q, and you did not compare it against the velocity of particle p, you would lose 1 point, so you get 1 out of 2 points on this question. And if you don't do the analysis, so if you don't say, since they have the same sign on these intervals, you miss both points for the question. And another common mistake that you could make would be only recognizing the interval of 5 to 8 and ignoring the interval of 1 to 3, since there's a gap of a negative interval between them. So that's the
major fracture.
So for part C of this question, you want to find the acceleration of particle q at time t equals 2, and you want to determine whether the speed of particle q is increasing, decreasing, or neither at time t equals 2, and you want to explain your answer with reasoning. So for the first part of this question, you're already given the velocity equation, and all you have to do is find the derivative of the velocity to find the acceleration, which is 2t minus 8. You then want to, because we're finding the acceleration at time t equals 2, you want to plug in the 2, and you'll find that your answer is, your acceleration at time t equals 2 is negative 4. You then, for the second part of this question, you want to find the velocity, and you want to find the sign of the velocity, which is positive, and this tells you that because the acceleration is negative and the velocity is positive, it'll tell you that the speed of particle q is decreasing at time t equals 2 because its signs are opposite. Now this is a 2-point question, and you'll receive 1 point for giving the correct acceleration at time t equals 2, and you'll receive another point for stating that the speed of particle q is decreasing at time t equals 2, and giving the correct reasoning for why it's decreasing. And a common mistake for this question is simply stating that because the acceleration is negative, that the speed of particle q is decreasing. But you actually have to mention the sign of the velocity and mention how the differing sign of velocity and acceleration is what makes the particle decreasing.
So for part D, we find the position of particle Q the first time it changes direction. We can plug 3 in for t into the equation, take the integral, sub in xq of 0 for 5, solve the equation, and it comes out to 23, so the object changes direction at t equals 3 because that's the first time the velocity flips. So I took the antiderivative for the scoring guidelines, used the initial condition, and the answer is correct, so this would be the correct solution.
Alright guys, now that we answered the security question, we can play League of Legends.
Oh no, the servers are down.
Oh no.